The last section in Unit 5 is Section 5.7, Comparing Fractions. So here we'll do the typical comparing fractions, which one is less than or greater than the other. But we also really want to develop an understanding of what is this fraction approximately. So using the idea of approximation. So if they look at the fraction 26 over 50, again, it may be hard for them to conceive of breaking something into 50 pieces, but I bet when you look at this, you say, it's a little bit more than 1/2. Okay, it's 1/50th more. So beyond just having them compare fractions, we also want to make benchmarks or values that they can compare their fractions to that give them a better sense or understanding of what the number or the fraction represents. So typically, in our old curriculum, if you had them determine which to compare two fractions and use a less than or greater sign, you may have, so this one has 3/7, 6/7, and you may say it's all good, the denominators are the same, 6 is more than 3, so 3/7 is less than 6/7, or 6/7 is greater than 3/7. And that's fine. And then another way, and generally books kind of streamline this idea. So if you had 2/5 and maybe, 7/9, okay, and you want to know which one is bigger, sometimes people use the cross multiplying. So they write an 18 here, and they write a 35 here, and they say 35 is bigger than 18. Students love this. They love cross multiplying. They cross multiply everything if you give them a chance to, especially because it takes fractions out of the picture. So now they don't have to think about the fraction. And the reason this works, if you haven't thought about it recently, is you're basically giving them a common denominator without actually rewriting the fraction that way. Multiplying 9 by 2 gives you the numerator here. 7 times 5 gives you the numerator for this fraction, and they have a common denominator. So even though this is a nice trick, sometimes tricks, if they don't have understanding behind them, it's not really developing their understanding, it's just having them give them a way of answering a question using math they don't understand. Okay, so the way we handle this in this section is we start by having them look at fractions with the same denominator and different numerators. And if they shade them in, they could kind of think of this as a number line if you work left to right, or they could look at the total amount of area that's shaded, and it's easy for them to compare which one is larger or the idea of which one is more. Okay. Here we have them plot the fractions on the number line, and again, it's important for them to realize the idea of relative placement. Okay, so if we have -3/6, that's to the left of 0, 2/6 is to the right of 0, so 2/6 must be greater. And they also need to see the idea, I know this isn't to scale, but that when we're working in the negative direction, that -1/6 is greater than -3/6 using relative positioning. Okay. And then we have the same idea with comparing fractions with the same numerator. Okay, so you can think of this, if you haven't taught this before, you're finding the same number of copies, but the unit fraction is smaller. So this is 2 copies or larger. The first one is 2 copies of 1/3. Here we have 2 copies of the unit fraction 1/4. I think that's 6. 2 copies of 1/6. And 2 copies of 1/8. Okay. So just like in the other problems we fix the denominator and compare the numerators, here we can fix the numerator and compare the denominators. Okay, but it's a little bit counterintuitive to students because they think, well, 4 is bigger than 3. So giving them some pictures and letting them see that 1/4 is smaller than 1/3, they can see how to compare numbers with the same numerator with different denominators. Okay, the bigger the denominator, the smaller the pieces, the smaller the fraction. Okay? And here's the same idea with some triple number lines. We'll be using these a lot in proportional reasoning section. Where 0 and 1 are scaled, you can have them plot these, and then they can see which one is further to the right or further to the left. And here are some examples. Here they have the same denominator, so they'll compare numerators. Here they have the same numerator, they compare denominators. Here they can look at these, and 2/5 is positive, so that could be one of their justifications, is that they know 2/5 is the greatest because it's positive. These are negative, they have the same numerator. We can compare the denominators, but also take into account that they're negative. Okay? So 3 and 3 here, same numerators, so we know 3/6 is bigger. Here and here, same denominators, we know 2/7 is smaller. Okay? So of course this won't work in every case. And again, finding a common denominator is a way to find it in every case. But this type of reasoning will give students a better understanding of the relative size of fractions. And then we kind of used this idea, or I mentioned this idea in the beginning of the video, using 1/2 or even quarters as benchmarks. Okay, I think we use quarters as benchmarks for decimals. For fractions, we're just going to look at 1/2. So it's good to know if you have a fraction and it's a proper fraction, you know it's between 0 and 1. Okay, but that's, if you don't think about the number too much, that's pretty much all you know. So having a benchmark, knowing if it's between 0 and 1/2 or between 1/2 and 1, gives students a better understanding of the fraction. They can also begin to understand if one number is greater than 1/2 and one number is less than 1/2. We don't even need to find a common denominator. We can use the transitive property to realize the number bigger than 1/2 is bigger than the number less than 1/2. Okay? So these images, you might even want to have them make some of these on their own. And you probably do this intuitively, so we'll compare a bunch of these. I like this one. So we're comparing 4/7 and 1/2 because it feels like it's kind of in the middle there. So is it bigger than or less than, greater than or less than 1/2? And you probably use this strategy, or maybe you have another one you can tell me about. I usually just divide 7 by 2. Well, that's 3.5. So that's half of 7. And notice in this picture, this is 3.5 is half of 7. So now I know 4/7 is bigger than 1. And I could say qualitatively it's bigger than 1/2. Qualitatively it's a little bit bigger than 1/2. It's close to 1/2. Okay? If we had something like 6/7, I could say, well, 3.5 is 1/2. This would go up to here, and it's bigger than 1/2, but it's also kind of close to 1 or closer to 1. Okay? So I know we don't like some of these qualitative assessments. We're quant people, but just having this general approximation feel for fractions is really useful for them. So we have students compare fractions using 1/2 as a benchmark, and then we give them these examples where they're using the transitive property, but we don't call it that, where one of them is equal to or less than 1/2, the other one is greater than or less than 1/2, and they determine which is bigger. So here, less than 1/2 equal 1/2, this is bigger. Here, 2/5 is less than 1/2, 4/7 is greater than 1/2, 4/7 is bigger. 4/8 equals 1/2, 3/7 is less than 1/2, 4/8 is bigger. Okay. So that's the general idea of those, and I think that's all she wrote. And there's examples like these in the Math AS questions that the students will answer as well, where they'll be working with these 1/2s as benchmarks.